Okay, so in this video, we're going to find the exact value of the sine inverse of 1. How are we going to do that? Remember, this is an angle, so I'm going to let theta equal the sine inverse of 1. Okay. Then theta is the angle. Now remember, your angle is stuck between what? It's stuck between pi over 2 and negative pi over 2. Okay? So I know my answer is between pi over 2 and negative pi over 2. And whose sine is equal to 1. The sine is equal to 1. All right? So if we think about this for just a tad bit, okay, how do I solve this? Well, if I take the sine of both sides, I get the sine of theta equals the sine of sine inverse of 1, which is equal to 1. All right, so this tells me that the sine of theta equals 1. Now remember, theta is between negative pi over 2 and pi over 2 by definition of inverse. Now let's think about sine of theta for just a second. Okay? Sine of theta looks like this. Now what did we say? We've restricted x to be, or our theta to be between pi over 2, negative pi over 2, and positive pi over 2. Okay? So where is sine of theta equal to 1? Well, down here it's negative 1. Right here it's 0. Up here it's 1. So what is my value? Theta equal to pi over 2, okay, gets me 1. All right, so this tells me that the sine inverse of 1 is pi over 2. Okay? So maybe, maybe we need a little table to help us remember. All right, so if you have your theta values, okay, and then sine theta here. So what are some critical values? Well, I'm doing everything between negative pi over 2 to pi over 2, right? So let's start with negative pi over 2. And then we're going to do negative pi over 3. Then we're going to do negative pi over 4. We're going to do negative pi over 6. We're going to do 0. We're going to do pi over 6. Pi over 4. Pi over 3. And then pi over 2. Okay? So maybe we need to go back to our triangle from our unit circle. And so what is the value of sine at 0 here? Well, we don't care. Well, I guess we kind of care, right? Sine of 0 is just the y value. That's 0. So theta equals 0. The next one is the pi over 6. This is the 30 degree angle here. So the 30 degree angle, what's going to happen? This is the y value is 1/2. Okay. At the 45 degree angle, pi over 4, my y value is no longer 1/2, but it's square root 2 over 2. Okay. Square root 2 over 2. And then the 60 degree angle, square root 3 over 2. Square root 3 over 2. And then the 90 degree angle, guess what? It's a unit circle, so that's just 1. You remember your little trick, square root 4 over 2, which is 2 over 2, which is 1, right? You see how it's literally, it starts out, it's like square root 0, square root 1, square root 2, square root 3, square root 4. Do you remember this trick from a while back? And you divide everything by 2 here, and then that gets you simplify that out, you'll get these values that you really want. Okay? So if you think about it, the y values from 0 to pi over 2 are positive, okay? But the y values from 0 to negative pi over 2, all those y values are going to be negative, okay? So literally, instead of having positives, we're going to have negatives, negatives, negative, and negative, okay? So now that you have these, you know all of these fancy values. Like, say you want to find exact value of the sine inverse of negative 1/2. How do I get the sine inverse of negative 1/2? Well, what do I know? Theta is equal to the sine of inverse of negative 1/2. And then if I do sine of both sides, okay, so I want theta is the angle between negative pi over 2 and pi over 2, whose sine equals negative 1/2. So that tells me that this is the sine of theta equals negative 1/2. Well, what do I plug in to get negative 1/2 here? Looks like I plug in negative pi over 6. Bingo. All right. So theta is equal to negative pi over 6. All right. Now, we don't, we got to be careful here, because you think about negative pi over 6, negative, I go in the clockwise direction to get to here. So it might be tempting to say, oh, look, this is like 11 pi over 6. But why is this not right? Because if you remember, theta has to be between two values, negative pi over 2 and positive pi over 2. We restricted our domain so that we would actually have an inverse function. Okay, so that's why we use the negative pi over 6 for our answer here. Okay, so if you've got this table here, it sure does make life a lot easier to just be like, boom, there's the answer right there. Okay, so say instead of finding the exact value though, that maybe you want to find an approximate value. Okay, because we have calculators for that stuff, right? So find approximate value of an inverse sine function. So approximate value for inverse sine function, so like the sine inverse of 1/3. This isn't one of those special values. We don't have something over here in our table that's equal to 1/3, do we? So we need a calculator, unless you're going to take Cal 2. In Cal 2, I'll teach you how to do this by hand, but until that point, you're going to need a calculator to do this. Okay, so how do I do this? Well, it's, we need to express our answer in radians rounded to the 2 decimal places. So round 2 decimal places, radians. Okay, so biggest thing is make sure that your calculator is in radian mode. So click the mode button and then make sure radian is selected. Okay, now exit out. So let's do the arc sine, that sine inverse, and let's do 1 divided by 3, close parentheses, hit enter. And so my answer is 0.3398. All right, now rounded to 2 decimals, that gets me 0.34. Okay. Now try a sine inverse of negative 1/4. Okay, sine inverse negative 1/4. O. Sine inverse negative 1/4, close parentheses, negative 0.25. Huh. Negative 0.25. Okay, so one thing that's really interesting, and maybe you're catching it, maybe you're not, but if you notice, for values of theta close to 0, like 1/3, negative 1/4, those are close to 0, they look like they're really close to what we plugged in, right? So that's actually something you'll learn in Cal 2 about a Taylor polynomial, that actually you can actually use the function y equals x to approximate sine of x close to 0. Okay, so just kind of a side note, you don't have to know this unless you go on to Cal 2. Okay, so that's just a little Easter egg for some of you hungry people. All right. The use of different properties. So what we'll do, we'll jump into that in a different video, but hopefully this kind of gives you an idea of finding approximate and exact values for the arcsine function. Okay, so I've been saying arcsine, maybe I should define this, because some textbooks define it. So y equals a sine inverse of x. Some textbooks, calculus textbooks, they say arc sine of x. Right now, the only notation I'm seeing is this first notation, but I'm just going through the book as I see it. But just so you know, if you see other textbooks that they say arc sine of x, those are the same thing, okay? So just, if I ever accidentally say arc sine, I mean the inverse function for sine.